is scaling dead, then why is Mark Zuckerberg building a 2 gigawatt data center in Louisiana?
Right.
Why is Amazon building these multi-gigawatt data centers? Why is Google? Why is Microsoft building multiple gigawatt data centers plus buying billions and billions of dollars of fiber to connect them together because they think, hey, I need to win on scale, so let me just connect all the data centers together with super high bandwidth so then I can make them act like one data center, right? Towards one job, right? So this whole like is scaling over narrative falls on its face when you see what the people who know the best are spending on.
Great to be here. Psyched you both are in the shop today. Dylan, this is one of the things we've been talking about all year, which is, how the world of compute is radically changing. So Bill, why don't you tell folks who Dylan is, and let's get started.
Yeah, we're thrilled to have Dylan Patel with us from SemiAnalysis. Dylan has quickly built, I think, the most respected research group on global semiconductor industry. And so what we thought we'd do today is dive deep on the intersection, I think, between everything Dylan knows from a technical perspective about the architectures that are out there, about the scaling, about the key players in the market globally, the supply chain, and the best and the brightest of people we know are all listening and reading Dylan's work, and then connect it to some of the business issues that our audience cares about and see where it comes out. What I was hoping to do is kind of get a moment in time snapshot of all the semiconductor activity that relates to this big AI wave and try and put it in perspective.
Dylan, how'd you get into this?
So when I was 8, my Xbox broke, and I have immigrant parents. I grew up in rural Georgia, so I didn't have much to do besides be a nerd, and I couldn't tell them I broke my Xbox. So I had to open it up, short the temperature sensor, and fix it, and that was the way to fix it. I didn't know what I was doing at the time, but then I stayed on those forums, and then I became a forum warrior, right? You see those people in the comments always yelling at you, Brad. It's like that was me, right, as a child, and you didn't know as a child then, but
awesome.
It was just like arguing with people online as a child, and then being passionate. As soon as I started making money, I was reading earnings from semiconductor companies and investing in them, with my internship money, and
awesome.
Reading technical stuff as well, of course, and then working a little bit, and then
And to just give us a quick thumbnail on SemiAnalysis today. Like, what is the business?
Yeah, so today we are a semiconductor research firm, AI research firm. We service companies. Our biggest customers are all hyperscalers, the largest semiconductor companies, private equity, as well as hedge funds. And we sell data around where every data center in the world is, what the power is in each quarter, how the build-outs are going. We sell data around fabs. We track all 1,500 fabs in the world. For your purposes, only 50 of them matter, but all 1,500 fabs around the world. Same thing with the supply chain of whether it be cables or servers or boards or transformer substation equipment. We try and track all of this on a very number-driven basis, as well as forecasting. And then we do consulting around those areas.
Yeah. So, I mean, Bill, you and I just talked about this. I mean, for Altimeter, our team talks with Dylan and Dylan's team all the time. I think you're right. He's quickly emerged really just through hustle, hard work, doing the grindy stuff that matters. I think is a benchmark for what's going on in the semiconductor industry. And we're at this, I suggested we're 2 years into this, maybe, this build out. And it's been hyper-kinetic. And one of the things Bill and I are talking about is as we enter the end of 2024, taking a deep breath, thinking about 25, 26 and beyond, because a lot of things are changing and there's a lot of debates. And it's going to have consequence for trillions of dollars of value in the public markets, in the private markets, how the hyperscalers are investing and where we go from here. So Bill, why don't you take us a little bit through the start of the questions?
Well, so I think if you're going to talk about AI and semiconductors, there's only one place to start, which is to talk about Nvidia broadly. Dylan, what percentage of global AI workloads do you think are on Nvidia chips right now?
So I would say if you ignored Google, it would be over 98%. But then when you bring Google into the mix, it's actually more like 70%. Because Google is really that large of a percentage of AI workloads, especially production workloads. They
By
have
production,
less,
you mean in-house workloads for Google?
Production as in things that are making money.
Gotcha.
Things that are making money, they're actually it's probably even less than 70%, right? Because you think about Google Search and Google Ads are the two of the largest AI-driven businesses in the world, right? The only things that are even comparable are like TikTok and Metas, right?
And those Google workloads, I think it's important just to kind of frame this. Those are running on Google's proprietary chips. They're non-LLM workloads, correct?
So Google's production workloads for non-LLM and LLM run on their internal silicon. And I think one of the interesting things is, yes, everyone will say Google dropped the ball on transformers and LLMs, right? How did OpenAI do GPT, right? And not Google. But Google was running transformers even in their search workload since 2018, 2019. The advent of BERT, which was one of the most well-known, most popular transformers before we got to the GPT madness, has been there in their production search workloads for years. So they run transformers on their own in their search and ads business as well.
The going back to this number you'd use, 98%. If you just look at, I guess, workloads people are purchasing to do work on their own, so you take the captives out, you're at 98, right? This is a dominant landslide at this moment in time.
Back to Google for a second. They also are one of the big customers of Nvidia.
They do buy a number of GPUs. They buy some for some YouTube video related workloads, internal workload, right? So not everything internal is Google is a TPU, right? They do buy some for some other internal workloads, but by and large, their GPU purchases are for Google Cloud to then rent out to customers,
right?
Because while they do have some customers for their internal silicon externally, such as Apple, the vast majority of their external rental business for AI in terms of cloud business is still GPUs.
And that's NVIDIA GPUs.
Correct, NVIDIA GPUs.
Why are they so dominant? Why is NVIDIA so dominant?
So I like to think of it as like a three-headed dragon, right? I would say every semiconductor company in the world sucks at software except for NVIDIA, right? So there's software. There's, of course, hardware. People don't realize that NVIDIA is actually just much better at hardware than most people. They get to the newest technologies first and fastest because they drive like crazy towards hitting certain production goals, targets. They get chips out faster than other people from thought design to deployed. And then the networking side of things, right? They bought Mellanox and they've driven really hard with the networking side of things. So those three things kind of combine to make a three-headed dragon that no other semiconductor company can do alone.
Yeah, I'd call out a piece you did, Dylan, where you helped everyone visualize the complexity of one of these modern cutting-edge NVIDIA deployments that involves the racks, the memory, the networking, the size of and scale of the whole thing. Super helpful.
I mean, there's this comparison oftentimes between companies that are truly standalone chip companies. They're not systems companies. They're not infrastructure companies, and NVIDIA. But I think one of the things that's deeply underappreciated is the level of competitive moats that NVIDIA has. Software is becoming a bigger and bigger component of squeezing efficiencies and, total cost of operation out of these infrastructures. So talk to us a little bit about that schema, that Bill's referring to. Like, there are many different layers of systems architecture and how that's differentiated from maybe, a custom ASIC or an AMD.
Right. So when you look broadly at the GPU, right, no one buys one chip for running an AI workload, right? Models have far exceeded that, right? You look at, today's leading edge models like GPT-4 was, over 1 trillion parameters, right? 1 trillion parameters is over 1 terabyte of memory. Right. You can't get a chip with that capacity. A chip can't have enough performance to serve that model, even if it had enough memory capacity. So therefore, you must tie together many chips together. And so what's interesting is that NVIDIA has seen that and built an architecture that has many chips networked together really well called NVLink. But funnily enough, and the thing that many ignore is that Google actually did this alongside Broadcom, and they did it before NVIDIA, right? Today everyone's freaking out about, or not freaking out, but like everyone's like very excited about NVIDIA's Blackwell system, right? It is a rack of GPUs. That is the purchased unit, right? It's not one server, it's not one chip, it's a rack. And this rack, it weighs 3 tons and it has thousands and thousands of cables and all these things that Jensen will probably tell you, right? Extremely complex. Interestingly, Google did something very similar in 2018, right? With the TPU. Now they couldn't do it alone, right? They know the software. They know what the compute element needs to be, but they didn't know anything. They can't do a lot of the other difficult things like package design, like networking. And so they had to work with other vendors like Broadcom to do this. And because Google had such a unified vision of where AI models were headed, they actually were able to build this system architecture that was optimized for AI. Right. Whereas at the time, NVIDIA was like, well, how big do we go? I'm sure they could have tried to scale up bigger, but what they saw as the primary workloads didn't require scaling to that degree. Right. Now everyone sort of sees this and they're running towards it. But NVIDIA's got Blackwell coming now. Competitors like AMD and others have to, make an acquisition recently to help them get into the system design. Right. Because building a chip is one thing, but building many chips that connect together, cooling them appropriately, networking them together, making sure that it's reliable at that scale is a whole host of problems that semiconductor companies don't have the engineers for.
Where would you say NVIDIA has been investing the most in incremental differentiation?
I would say for differentiating, NVIDIA has primarily focused on supply chain things, which, might sound like, oh, well, they're just ordering stuff. No. You have to work deeply with the supply chain to build the next generation technology so that you can bring it to market before anyone else does, right? Because if NVIDIA stands still, they will be eaten up, right? They're, sort of the Andy Grove, only the paranoid will survive. Jensen is probably the most paranoid man in the world,
yes.
Right? He's known for many years, since before the LLM craze, all of his biggest customers were building AI chips, right? Before the LLM craze, his main competitors were like, oh, we should make GPUs. And yet he stays on top because he's bringing to market technologies at volume that no one else can, right? And so whether it be in networking, whether it be in optics, whether it be in water cooling, right? Whether it be in, all sorts of other power delivery, all these things, he's bringing to market technologies that no one else has. And he has to work with the supply chain and teach those supply chain companies, and they're helping obviously have their own capabilities to build things that don't exist today. And NVIDIA is trying to do this on an annual cadence now.
That's incredible,
right?
yeah.
Blackwell Ultra, Rubin Ultra. They're going so fast. They're driving so many changes every year. Of course, people are gonna be like, oh no, there's some delays in Blackwell. Yeah, of course look how hard you're driving the supply chain.
Yeah.
Is that part, how big a part of the competitive advantage is the fact that they're now on this annual cadence? Right? Because it seems like by going there, it almost precludes their competitors from catching up, because even if you skate to where Blackwell is, right, you're already on next generation within 12 months. He's already planning 2 or 3 generations ahead because it's only 2 to 3 years ahead.
Well, the funny thing is, a lot of people at NVIDIA will say Jensen doesn't plan more than a year and a half out, right. Because they change things and they'll deploy them out that fast, right? Every other semiconductor company takes years to deploy, make architecture changes. But
you said if they stand still, they would have competition. Like what would be their area of vulnerability, or what would have to play out in the market for other alternatives to take more share of the workloads?
Yeah, so the main thing for NVIDIA is, hey, this workload is this big, right? It's well over $100 billion of spend. For the biggest customers, they have multiple customers that are spending billions of dollars.
Yep.
I can hire enough engineers to figure out how to run my model on other hardware, right? Now, maybe I can't figure out how to train on other hardware, but I can figure out how to run it for inference on other hardware. So NVIDIA's moat in inference is actually a lot smaller on software, but it's a lot bigger on, hey, they just have the best hardware. Now, what does the best hardware mean? It means capital cost, and it means operation cost, and then it means performance, right? Performance, TCO.
Yes.
And NVIDIA's whole moat here is if they stand still, their performance TCO doesn't grow. But interestingly, they are, right? Like with Blackwell, not only is it way, way, way faster, anywhere from 10 to 15 times on really large models for inference, because they've optimized it for very large language models, they've also decided, hey, we're going to cut our margin too somewhat, because I'm competing with Amazon's chip and TPU and AMD and all these things. They've decided to cut their margin too. So between all these things, they've decided that they need to push performance TCO, not 2x every 2 years, right? Moore's law, right? They've decided they need to push performance TCO 5x, maybe every year, right? At least that's what Blackwell is, and we'll see what Rubin does. But 5x plus in a single year for performance TCO is an insane pace, right? And then you stack on top like, hey, AI models are actually getting a lot better for the same size. The cost for delivering LLMs is tanking, which is going to induce demand, right? So this
just to clarify one thing you said, or at least restate it to make sure I think when you said the software is more important for training, you meant CUDA is more of a differentiator on training than it is on inference.
So I think a lot of people in the investor community, call CUDA, which is just like one layer for all of NVIDIA software. There's a lot of layers of software, but for simplicity's sake, regarding networking or what runs on switches or what runs on, all sorts of things, fleet management stuff, all sorts of stuff that NVIDIA makes that we'll just call CUDA for simplicity's sake. But all of this software is stupendously difficult to replicate. In fact, no one else has deployments to do that besides the hyperscalers, right? And a few thousand GPUs is like a Microsoft inference cluster, right? It's not a training cluster. So when you talk about, hey, what is the difficulty here, right? On training, this is users constantly experimenting, right? Researchers saying, hey, let's try this, let's try that, let's try this, let's try that. I don't have time to optimize and hand wring out the performance. I rely on NVIDIA's performance to be quite good with existing software stacks or very little effort, right? Mm-hmm. But when I go to inference, Microsoft is deploying 5-6 models across how many billions of revenue, right? So all of OpenAI's revenue plus whatever they have in Copilot.
They said 10 billion of inference revenue.
Yeah, so they have $10 billion of revenue here, and they're deploying 5 models, right? GPT-4, 4.0, 4.0 mini, and now, the reasoning models, 0.1 and yeah. So it's like they're deploying very few models, and those change every 6 months. Right. So every 6 months they get a new model and they deploy that. So within that time frame, you can hand wring out the performance. And so Microsoft has deployed GPT style models on other competitors' hardware, such as AMD. And some of their own, but mostly AMD. And so they can wring that out with software because they can spend hundreds of engineers. Right. Dozens of engineers hours, hundreds of engineer hours, or thousands of engineer hours on working this out because it's such a unified sort of workload, right?
I want to get you to comment on this chart. This is a chart we showed earlier in the year that I think was kind of a moment for me with Jensen when he was in, I think, the Middle East. And for the first time, he said, not only are we going to have $1 trillion of new AI workloads over the course of the next 4 years, he said, but we're also going to have $1 trillion of CPU replacement, of data center replacement workloads over the course of the next 4 years. So that's an effort to model it out. And we referenced it on the pod with him, and he seemed to indicate that it was directionally correct, right? That he still believes that it's not just about, because there's a lot of fuss in the world about, pre-training and what if pre-training doesn't continue apace. And it seemed to suggest that there was a lot of AI workloads that had nothing to do with pre-training that they're working on, but also that they had all of this data center replacement. Do you buy that? I've heard a lot of people push back on the data center replacement and say there's no way people are going to, rebuild a CPU data center with a bunch of Nvidia GPUs. It just doesn't make any sense. But his argument is that an increasing number of these applications, even things like Excel and PowerPoint, are becoming machine learning applications and require accelerated compute.
NVIDIA has been pushing non-AI workloads for accelerators for a very long time, right? Professional visualization, right? Pixar uses a ton of GPUs, right, to make every movie. All these Siemens engineering applications, right? All these things do use GPUs, right? I would say they're a drop in the bucket compared to, AI. The other aspect I would say is, and this is sort of a bit contentious with your chart, I think, but IBM mainframes sell more volume and revenue every single cycle. Right. So, yes, no one in the Bay uses mainframes or talks about mainframes, but they're still growing. Yeah. Right. And so I would say the same applies to CPUs, right? To classic workloads. Just because, AI is here doesn't mean web serving is going to slow down or databasing is going to slow down. Now, what does happen is that line is like this and the AI line is like this. And furthermore, right, like when you talk about hey, these applications, they're now AI, right? Excel with Copilot or Word with Copilot or whatever, right? they're still going to have all of those classic operations. You don't get rid of what you used to have, right? Southwest doesn't stop booking flights.
Right.
They just run AI analytics on top of their flights to maybe, do pricing better or whatever, right? So I would say that still happens, but there is an element of replacement that is sort of misunderstood, right? Which is, given how much people are deploying, how tight the supply chains for data centers are. Data centers take longer, they're longer time supply chains, unfortunately, right? Which is why you see things like what Elon's doing. But when you think about that, well, how can I get power then, right? So you can do what CoreWeave is doing and go to crypto mining companies and just like clear them out and put a bunch of GPUs in them, right? Retrofit the data center, GPUs in them like they're doing in Texas. Or you can do what some of these other folks are doing, which is, hey, well, my depreciation for CPU servers has gone from 3 years to 6 years in just a handful of years. Why? Because Intel's progress has been this, right?
Right.
So in reality, like the old Intel CPU is not that much better. But all of a sudden, over the last couple years, AMD's burst onto the scene, ARM CPUs have burst onto the scene, Intel's started to right the ship. Now I can upgrade the plurality of Amazon's CPUs in their data centers are 24 core Intel CPUs that were manufactured from 2015 to 2020. More or less the same architecture. There's 24 core CPU.
Right.
I can buy a 128 or 192 core CPU now today, where each CPU core is higher performance. And well, if I just replace like 6 servers with one, I've basically invented power out of thin air, right? I mean, like, in effect, because these old servers, which are 6+ years old, or even, they can just be deprecated and put. So with CapEx of new servers, I can replace these old servers. And now, every time I do that, I can throw another AI server in there, right? So this is sort of yes, there is some replacement. I still need more total capacity, but that total capacity can be served by fewer machines, maybe, if I buy new ones. And generally, the market is not going to shrink. It's still going to grow, just nowhere close to what AI is. And AI is causing this behavior of, I need to replace so I can get power.
Hey, Bill, this reminds me of a point Satya made on the pod last week that I've seen replayed a bunch of times and I think is fairly misunderstood. He said last week on the pod that he was power and data center constrained, not chip constrained. What I think it was more an assessment on the real bottleneck, which is data centers and power, as opposed to GPUs, because GPUs have come online. And so I think the case you just made, I think, helps to clarify that.
Well, before we dive into the alternatives to Nvidia, I thought we would hit on this pre-training scaling debate that you wrote about in your last piece, Dylan, and we've already talked about quite a bit. But why don't you give us your view of what's going on there? I think Ilya was the most credible AI specialist that brought this up, and then it got repeated and cross-analyzed quite a bit.
And Bill, just to repeat what it is,
fair enough.
I think Ilya said, data is the fossil fuel of the internet of AI, that we've consumed all the fossil fuel because we only have but one internet. And so the huge gains we got from pre-training are not going to be repeated.
And some experts had predicted that data would run out a year or two ago. So it wasn't like out of nowhere that argument came to light. Anyway, let's hear what Dylan has to say.
So pre-training scaling laws are pretty simple, right? You get more compute, and then I throw it at a model, and it'll get better. Now, what is that? That breaks out into 2 axes, right? Data and parameters, right? The bigger the model, the more data, the better. And there's actually an optimal ratio, right? So Google published a paper called Chinchilla, which says the optimal ratio of data to parameter, model size. And that's the scaling thing. Now, what happens when the data runs out? Well, I don't really get much more data,
right,
but I keep growing the size of the model because my budget for compute keeps growing. This is a bit not fair though, right? We have barely tapped video data. Right? So there is a significant amount of data that's not tapped. It's just video data is so much more information than written data, right? And so therefore you're throwing that away. But I think that's part of that there's a bit of misunderstanding there. But more importantly, text is the most efficient domain, right? Humans generally, yes, a picture paints 1,000 words, but if I write 100 words, you can figure out faster.
And
right?
the transcripts of most of those videos were already.
Yeah, the transcripts of many of those videos are in there already, but regardless, the data is like a big axis. Now, the problem is this is only pre-training, right? Quote, pre. Training a model is more than just the pre-training, right? There's many elements of it. And so people have been talking about, hey, inference time compute. Yeah, that's important, right? You can continue to scale models if you figure out how to make them think and recursively be like, oh, that's not right. Let me think this way. Oh, that's not right. Much like, you don't hire an intern and say, hey, what's the answer to X? Or you don't hire a PhD and say, hey, what's the answer to X? You're like, go work on this. And then they come back and bring something to you. So inference time compute is important, but really what's more important is as we continue to get more and more compute, can we improve models if data is run out? And the answer is you can create data out of thin air almost, right? In certain domains, right? And so this is the debate around scaling laws is how can we create data, right? And so what is Ilya's company doing? Most likely. What is Mira's company doing? Most likely. Mira Murati, CTO of OpenAI. What are all these companies focused on? OpenAI. What are all these companies focused? They have Noam Brown, who's like sort of one of the big reasoning people on road shows, just going and speaking everywhere, basically, right? What are they doing, right? They're saying, hey, we can still improve these models. Yes, spending compute at inference time is important, but what do we do at training time? Because you can't just tell a model, think more and it gets better. You have to do a lot at training time. And so what that is I take the model, I take an objective function I have, right? What is the square root of 81? Right? Now, if I told you asked many people what's the square root of 81, many could answer, but I bet many people could answer if they thought about it more, like almost, a lot more people, right? Maybe it's a simplistic problem. But you say, hey, let's have the existing model do that. Let's have it just run every possible, not every possible, but many permutations of this. Start off with, say, 5, and then anytime it's unsure, branch into multiple. So you start out, you have hundreds of quote unquote rollouts or trajectories of generated data. Most of this is garbage, right? You prune it down to, hey, only these paths got to the right answer. Right. Okay, now I feed that, and that is now new training data. Yeah. And so I do this with every possible area where I can do functional verification. Functional verification, i.e., hey, this code compiles. Hey, this unit test that I have in my code base, how can I generate the solution? How can I generate the function? Okay, now, and you do this over and over and over and over again across many, many, many different domains where you can functionally prove it's real. You generate all this data, you throw away the vast, vast majority of it, but you now have some chains of thought that you can train the model on, which then it will learn how to do that more effectively, and it generalizes outside of it, right? And so this is the whole domain. Now, when you talk about scaling laws, it's point of diminishing returns is kind of not proven yet, by the way, right? Because it's more so, hey, the scaling laws are a log axis. A log, i.e., it takes 10x more investment to get the next iteration. Well, 10x more investment, going from 30 million to 300 million, 300 million to 3 billion is relevant. But when Sam wants to go from 3 billion to 30 billion, right, it's a little difficult to raise that money, right? That's why, the most recent rounds are a bit like, oh, crap, we can't spend 30 billion on the next run. Right. And so the question is, well, that's just one axis. Where have we gone on synthetic data? Oh, we're still like very early days, right? We've spent tens of millions of dollars maybe on synthetic data.
With synthetic data, you used a qualifier in certain domains. When they released 01, it also had a qualifier like that in certain domains. I'm just saying those two scaling axes do better in certain domains and aren't as applicable in others, and we have to figure that out.
Yeah, I think one of the interesting things about AI is at first in 2022, 2023, with the release of diffusion models, with the release of text models, people are like, oh wow, artists are the one that are the most, out of luck, not technical jobs. Actually, these things suck at technical jobs. But with this new axis of synthetic data and test time compute, actually, where are the areas where we can teach the model? We can't teach it what good art is because we have no way to functionally prove what good art is. We can teach it to write really good software. We can teach it how to do mathematical proofs. We can teach it how to engineer systems because while there are trade-offs, and this is not like, it's not just a 1-0 thing, especially on engineering systems, this is something you can functionally verify. Is this works or not? Or this is correct or not?
Grade the output, and then the model can iterate more often.
Exactly.
It goes back to the AlphaGo thing and why that was a sandbox that could allow for novel moves and plays because you could traverse it and run synthetically. You could just let it create and create and create.
putting on my investor hat, public investor hat here, there is a lot of tension in the world over NVIDIA as we look forward at 2025 and this question of pre-training, right? And if in fact, we plucked 90% of the low-hanging fruit that comes from pre-training, then do people really need to buy bigger clusters? And I think there's a view in the world, particularly post Ilya's comments, that, no, the 90% benefit of pre-training is gone. But then I look at, the comments out of Hock Tan this week, during their earnings call that all the hyperscalers are building these million, XPU clusters. I look at, the commentary out of X.AI that they're going to build 200 or 300,000 GPU clusters. Meta reportedly building much bigger clusters. Microsoft building much bigger clusters. How do you square those two things, right? If everybody's right and pre-training's dead, then why is everybody building much bigger clusters?
So the scaling, right, goes back to what's the optimal ratio? How do we continue to grow, right? Just blindly growing parameter count when we don't have any more data, or the data is very hard to get at, i.e. because it's video data, wouldn't give you so many gains. And then there's also the axis of it's a log chart, right? You need 10x more to get the next jump.
Correct.
Right? So when you look at both of those, oh crap, I need to invest 10x more. And I might not get the full gain because I don't have the data. But the data generation side, we are so early days with this, right?
So the point is, I'm still going to squeak out enough gain that it's a positive return, particularly when you look at the competitive dynamic, our models versus our competitor models. So it's a rational decision to go from 100,000 to 200,000 or 300,000, even if, the kind of big one-time gain in pre-training is behind us.
Or rather, it's exponentially more, it's logarithmically more expensive to do that gain.
Correct.
Right? So it's still there. The gain is still there, but the sort of whole Orion has failed sort of narrative around OpenAI's model, and they didn't release Orion, right? They released O1, which is sort of a different axis. It's partially because, hey, this is, because of these data issues, but it's partially because they did not scale 10x, right? Because scaling 10x from 4 to this was I
think this is Gavin's point, right?
Well, I would also, let's go to Gavin in a second. One of the reasons this became controversial, I think, is, and I don't know, Dario and Sam had, prior to this moment, or at least the way I heard them, made it sound like they were just going to build the next biggest thing and get the same amount of gain. They had left that impression. And so we get to this place as you described it, it's not quite like that. And then people go, oh, what does that mean? It causes them to raise their head up.
So I think they have never said the chinchilla scaling laws were what delivers us, AGI, right? They've had scaling. Scaling is, you need a lot of compute. And guess what? If you have to generate a ton of data and throw away most of it because, hey, only some of the paths are good, you're spending a ton of compute at train time. Right. And this is sort of the axis that is we may actually see models improve faster in the next 6 months to a year than we saw them improve in the last year, because there's this new axis of synthetic data generation, and the amount of compute we can throw at it is we're still right here in the scaling law. Right. We're not here. We haven't pushed it to billions of dollars spent on synthetic data generation, functional verification, reasoning, training. We've only spent millions, tens of millions of dollars, right? So what happens when we scale that up? So there is a new axis of spending money. And then there's, of course, test time compute as well, i.e. spending time at inference to get better and better. So it's possible, and in fact, many people at these labs believe that the next year of gains or the next 6 months of gains will be faster because they've unlocked this new axis through a new methodology, right? And it's still scale, right? Because this requires stupendous amounts of compute. You're generating so much more data than exists on the web, and then you're throwing away most of it, but you're generating so much data that you have to run the model constantly, right?
What domains do you think are most applicable with this approach? Where will synthetic data be most effective? And maybe you could do both a pro and a scenario where it's going to be really good and one where it wouldn't work as well.
Yeah, so I think that goes back to the point around what can we functionally verify is true or not? What can I grade and it's not subjective? What class can you take in college and you get the thing back and you're like, oh, this is BS, or you're like, dang, I messed that up, right? There's certain classes where you can
a determinism of grading the output.
Right, exactly. So if it can be functionally verified, amazing. If it has to be judged, right? So there's sort of two ways to judge an output, right? There is, without using humans, right? This is sort of the whole scale AI, right? What were they initially doing? They were using a ton of manpower to create good data, right? Label data. But now humans don't scale for this level of data, right? Humans post on the internet every day, and we've already tapped that out, right? Kind of more or less on the text domain.
What are domains that work?
So these are domains where, hey, in Google, when they push data to any of their services, they have tons of unit tests. These unit tests make sure everything's working. Well, why can't I have the LLM just generate a ton of outputs and then use those unit tests to grade those outputs, right? Because it's pass or fail, right? It's not. And then you can also like grade these outputs in other ways, like, oh, it takes this long to run versus this long to run. So then you have there's other areas such as like, hey, image generation. Well, actually it's harder to say which image looks more beautiful to you versus me. I might like, some like sunsets and flowers, and you might like the beach, right? You can't really argue what is good there. So there's no functional verification. There is only subjective, right? So the objective nature of this is where do we have objective grading? Right? We have that in code. We have that in math. We have that in engineering. And while these can be complex, like, hey, engineering is not just this is the best solution. It's, hey, given all the resources we've had and given all these trade-offs, we think this is the best trade-off, right? That's usually what engineering ends up being. Well, I can still look at all these axes, right? Whereas in subjective things, right? Like, hey, what's the best way to write this email, or what's the best way to negotiate with this person? That's difficult, right? That's not something that is objective.
What are you hearing from the hyperscalers? I mean, they're all out there saying our CapEx is going up next year. We're building larger clusters. Is that in fact happening? Like, what's happening out there?
Yeah, so I think when you look at the street's estimates for CapEx, they're all far too low. Based on a few factors, right? So when we track every data center in the world, and it's insane how much, especially Microsoft and now Meta and Amazon and many others, right? But those guys specifically are spending on data center capacity, and as that power comes online, which you can track pretty easily if you look at all of the different regulatory filings and use satellite imagery, all these things that we do, you can see that, hey, they're going to have this much data center capacity, right?
Right.
It's
accelerating.
What are you going to fill in there, right?
Yeah.
It turns out you have to fill it up. You can make some estimates around how much power is each GPU, all in, everything, right? Satya said he's going to slow down that a little bit, but they've signed deals for next year rentals, right? In some of these cases, right?
And as part of the reason he said is he expects his cloud revenue in the first half of next year to accelerate, because he said we're going to have a lot more data center capacity, and we're currently capacity constrained. So,
what they're, like, again, going back to is scaling dead? Then why is Mark Zuckerberg building a 2 gigawatt data center in Louisiana?
Right.
Why is Amazon building these multi-gigawatt data centers? Why is Google? Why is Microsoft building multiple gigawatt data centers plus buying billions and billions of dollars of fiber to connect them together, because they think, hey, I need to win on scale, so let me just connect all the data centers together with super high bandwidth, so then I can make them act like one data center, right? Towards one job, right? So this whole like is scaling over narrative falls on its face when you see what the people who know the best are spending on, right?
You talked a lot at the beginning about Nvidia's differentiation around these large coherent clusters that are used in pre-training. Can you see anything like, I guess someone might be super bullish on inference and keep building out a data center, but they might have thought they were going to go from 100,000 nodes to 200 to 400 and might not be doing that right now if this pre-training thing is real. Are you seeing anything that gives you any visibility on that dimension?
So when you think about training a neural network, right, it is doing a forwards pass and a backwards pass, right? Forwards pass is generating the data basically, and it's half as much compute as the backwards pass, which is updating the weights. When you look at this new paradigm of synthetic data generation, grading the outputs, and then training the model, you are going to do many, many, many forward passes before you do a backwards pass. What is serving a user? That's also just a forwards pass. So it turns out that there is a lot of inference in training, right? Mm-hmm. In fact, there's more inference in training than there is updating the model weights, because you have to generate hundreds of possibilities, and then, you only train on a couple of them, right? So there is, that paradigm is very relevant. The other paradigm I would say that is very relevant is when you're training a model, do you necessarily need to be co-located for every single aspect of it?
Right.
Right. And what's
the answer?
The answer is Depends on what you're doing. If you're in the pre-training paradigm, then maybe you don't, you need it to be co-located, right? You need everything to be in one spot. Yeah, why did Microsoft in Q1 and Q2 sign these massive fiber deals, right? And why are they building multiple similar sized data centers in Wisconsin and Atlanta and Texas and so on and so forth, right? And Arizona. Why are they doing that? Because they already see the research is there for being able to split the workload more appropriately, which is, hey, this data center, it's not serving users, it's running inference. It's just running inference and then throwing away most of the output because some of the output is good. And because I'm grading it, right? And they're doing this while they're also updating the model in other areas. So the whole paradigm of training, pre-training is not slowing down. It's just it's logarithmically more expensive for each generation, for each incremental improvement.
So people are finding other ways to.
But there's other ways to not just continue this, but hey, I don't need a logarithmic increase in spend to get the next generation of improvement. In fact, through this reasoning, training, and inference, I can get that logarithmic improvement in the model without ever spending that. Now I'm gonna do both, right? Because because each model jump has unlocked huge value, right?
I mean, the thing that I think so interesting, I hear Kramer on CNBC this morning, and they're talking about, is this Cisco from 2000? I was in Omaha, Bill, Sunday night for dinner. They're obviously big investors in utilities, and they're watching what's going on in the data center build out. And they're like, is this Cisco from 2000? So I had my team pull up a chart for Cisco, 2000, and we'll show it on the pod. But, they peaked at like 120 PE. Right. And, if you look at the fall off that occurred in revenue and in EBITDA, and then it had 70% compression in the price to earnings multiple. Right. So the price to earnings multiple went from 120 down to something closer to 30. And so I said to, in this dinner conversation, I said, well, Nvidia's, PE today is 30. It's not 120. Right. So you would have to think that there would be 70% PE compression from here, or that their revenue was going to fall by 70%, or that their earnings were going to fall by 70%, in order to have a Cisco-like event. We all have post-traumatic stress about that. I mean, hell, I lived through that too. Nobody wants to repeat that. But when people make that comparison, it strikes me as uninformed. Right. It's not to say that there can't be a pullback, but given what you just told us about the build out next year, given what you told us about scaling laws continuing, what do you think when you hear, the Cisco comparison when people are talking about Nvidia?
Yeah, so I think there's a couple things that are not fair, right? Cisco's revenue, a lot of it was funded through private/credit investments into building out telecom infrastructure. Right? When we look at NVIDIA's revenue sources, very little of it is private/credit, right? And in some cases, yes, it's private/credit like CoreWeave, right? Mm-hmm. But CoreWeave is just backstopped by Microsoft. There is significant amounts of difference in what is the source of the capital, right? The other thing is at the peak of the .com, especially once you inflation adjust it, the private capital entering the space was much larger than it is today, right? As much as people say the venture markets are going crazy, throwing these huge valuations at, all these companies, and we were just talking about this before the show, but hey, the venture markets, the private markets have not even tapped in, right? Guess what? Private market money in the Middle East, in these sovereign wealth funds, it's not coming in yet, has barely come in, right? Why wouldn't there be a lot more spend from them as well, right? And so there is a significant amount of the difference of capital. The source is positive cash flows of the most profitable companies that have ever lived or ever existed in humanity versus credit speculatively spent, right? So I think that is a big aspect. That also gives it a bit of a knob, right? These companies that are profitable will be a bit more rational.
I think corporate America is investing more in AI and with more conviction than they did even in the internet wave also.
Maybe we can switch a little bit. You've mentioned inference time reasoning a few times now. It's clearly a new vector of scaling intelligence. And I read some of your analysis recently about how inference time reasoning is way more compute intensive, right, than simply pre-train, scaling pre-training. Why don't you walk us through? We have a really interesting graph here about why that's the case that we'll post as well. But why don't you walk us through first just kind of what inference time reasoning is from the perspective of compute consumption, why it's so much more compute intensive, and so leading to the conclusion that if this is in fact going to continue to scale as a new vector of intelligence, it looks like it's going to be even more compute intensive than what came before it.
Yeah, so pre-training may be slowing out or it's too expensive, but there's these other aspects of synthetic data generation and inference time compute. Inference time compute is, on the surface, sounds amazing, right? I don't need to spend more training a model. But when you think about it for a second, this is actually very, very, this is not the way you want to scale. You only do that because you have to, right? Think about it. GPT-4 was trained with hundreds of millions of dollars, and it's generating billions of dollars of revenue.
Hundreds of millions of dollars.
Hundreds of millions of dollars to train GPT-4.
Yep.
And it's generating billions of dollars of revenue. So when you say like, hey, Microsoft's CapEx is nuts, sure, but their spend on GPT-4 was very reasonable relative to the ROI they're getting out of it, right? Now, when you say, hey, I want the next gain, if I just spend, sort of a large amount of capital and train a better model, awesome. But if I don't have to spend that large amount of capital and I deploy it, I deploy this better model without, at the time of revenue generation rather than ahead of time when I'm training the model, this also sounds awesome. But this comes with this big trade-off, right? When you're running reasoning, right, you're having the model generate a lot. And then the answer is only a portion of that, right? Today, when you open up ChatGPT, you use GPT-4, 4.0, you say something, you get a response.
Correct.
You send something, you get a response, whatever it is, right? All of the stuff that's being generated is being sent to you. Now you're having this reasoning phase, right? And OpenAI doesn't want to show you, but there's some open source Chinese models like Alibaba and DeepSeek. They've released some open source models, which are not quite as good as OpenAI, of course, but they show you what that reasoning looks like if you want to. And OpenAI has released some examples. It generates tons of things. It's like, it sometimes switches between Chinese and English, right? Like whatever it is, it's thinking, right? It's churning. Right. It's like this. Oh, should I do it this way? Should I break it down in these steps? And then it comes out with an answer, right? Now, on the surface, awesome. I didn't have to spend any more on R&D or capital, right? I'm saying this in the loose terms. They don't treat training models as R&D. I think on Microsoft on a financial basis, but they don't have to treat this. They don't have this R&D ahead of time, right? You get it at spend time. But think about what that means, right? If for you, right? For example, one simple thing that we've done a lot of tests on is, hey, generate me this code, right? Like make this function. Great. I describe the function in, a few hundred words. I get back a response that's, 1,000 words. Awesome. And I'm paying per token. Right. When I do this with O1 or any other reasoning model, I'm sending the same response, right? Few hundred tokens. I'm paying for that. I'm getting the same response, roughly, 1,000 tokens. But in the middle, there was 10,000 tokens of it thinking. Right. Now, what does that 10,000 tokens of thinking actually mean? It means, well, the model's spitting out 10 times as many tokens. Well, if Microsoft's generating, call it $10 billion of inference revenue, and their margins on that are good, they've stated this, right? They're anywhere from 50 to 70%, depending on how you count the OpenAI profit share. Anywhere from 50 to 70% gross margins. Their cost for that is a few $1 billion for $10 billion of revenue. Right. Now, obviously, the better model gets to charge more, right? So O1 does charge a lot more, but you're now increasing your cost from, hey, I outputted 1,000 tokens to I outputted 11,000 tokens. I've 10x'd my spend to generate, now, not the same thing, right? It's higher quality, correct? Right? And that's only part of it. That's deceptively simple. It's not just 10x, right? Because if you go look at O1, despite it being the same model architecture as GPT-4o, it actually costs significantly more per token as well. And that's because of, sort of this chart that we're looking at here, right? And this chart shows, hey, what is GPT-4o, right? If I'm generating, call it 1,000 tokens, right? And that's what GPT-4o on the bottom right is. Of Llama 405B, this is an open model, so it's easier to simulate, the exact metrics of it. But, if I'm doing that, I'm keeping my users, experience of the model constant, i.e. the number of tokens they're getting at the speed. Then, when I ask it a question, it generates the unit, it generates the code, whatever it is. I can group together many users' requests. I can group together over 256 users' requests on one server for Llama 405B of Nvidia server, right? Like, $300,000 server or so. When I do this with O1, right, because it's doing that thinking phase of 10,000, right? This is basically the whole context length thing. Context length is not free, right? Context length or sequence length means that it has to calculate attention, the attention mechanism, i.e. it spends a lot of memory on generating this KV cache and reading this KV cache constantly. Now the maximum batch size, i.e. concurrent users I can have, is a fraction of that, 1/4 to 1/5 the number of users can currently use this server. So not only do I need to generate 10x as many tokens, each token that's generated is 4 to 5x less users. So the cost increase is stupendous when you think about a single user. Cost increase for a single token to be generated is 4 to 5x, but then I'm generating 10x as many tokens. So you could argue the cost increase is 50x for an O1 style model on input to output.
I knew the 10x because it was on the original O1 release, but with the log scale, but I didn't know.
Well, it's 10x.
And it just requires you to have, again, to service the same number of customers, you have to have multiples more compute.
Well, there's good news and bad news here, Brad, which I think is what Dylan's telling us. Like, if you're just selling NVIDIA hardware and they remain the architecture, and this is our scaling path, you're going to consume way more of it.
Correct. But the margins for the people who are generating on the other end, unless they can pass it on to the end consumer, are gonna compress.
And the thing is, you can pass it on to the end consumer because, hey, it's not really like, oh, it's X% better on this benchmark. It literally could not do this before, and now it can, right? And they're
running a test right now where they're 10xing what they're charging the end consumer, and
it's 10x per token, right?
Correct.
Remember, they're also paying for 10x as many tokens, right? So it's actually, the consumer is paying 50x more per query,
right?
But they're getting value out of it because now all of a sudden it can pass certain benchmarks like SWE-bench, right? Software engineering benchmark, right? Which is just a benchmark for generating decent code, right? There's front-end web development, right? What do you pay front-end web developers? What do you pay back-end developers? Versus, hey, what if they use O1? How much more code can they output? How much more can they output? Yes, the queries are expensive, but they're nothing close to the human, right? And so each level of productivity gain I get, each level of capabilities jump is a whole new class of tasks that it can do, right? And therefore I can charge for that, right? So this is the whole axis of, yes, I spend a lot more to get the same output, but you're not getting the same output with this model.
Are we overestimating or underestimating end demand, enterprise level demand for the O1 model? What are you hearing?
So I would say the O1 style model is so early days, people don't even get it, right? O1 is they just cracked the code and they're doing it, but guess what? Right now on, some of the anonymous benchmarks, there are, it's called LLM Sys, which is an arena where different LLMs get to compete sort of, and people vote on them. There's a Google model that is doing reasoning right now, and it's not released yet, but it's going to be released soon enough, right? Anthropic is going to release a reasoning model. These people are going to one-up each other, and also they've spent so little compute on reasoning right now in terms of training time. And they see a very clear path to spending a lot more, i.e. jumping up the scaling laws. Oh, I only spent $10 million. Well, wait, that means I can jump up 2 to 3 logarithms in scaling like that because I've already got the compute. I can go from $10 million to $100 million to $1 billion to $10 billion on reasoning in such a quick succession. And so the performance improvements we'll get out of these models is humongous, right? In the coming, 6 months to a year in certain benchmarks where you have functional verifiers.
Quick question, and we promised we'd go to these alternatives, so we'll have to get there eventually. But if you go back, we've used this internet wave comparison multiple times. When all of the venture-backed companies got started on the internet, they were all on Oracle and Sun. And 5 years later, they weren't on Oracle or Sun. And some have argued it went from a development sandbox world to a optimization world. Is that likely to happen? Is there an equivalency here or not? And if you could touch on why the back end is so steep and cheap, just you go a model behind, or you the price you can save by just backing up a little bit is nutty.
Yeah. So today, right, O1 is stupendously expensive. You drop down to 4.0, it's a lot cheaper. You jump down to 4.0 mini, it's so cheap. Why? Because now with 4.0 Mini, I'm competing against Llama, and I'm competing against DeepSeek. I'm competing against Mistral. I'm competing against Alibaba, and I'm competing against tons of companies. So you
think those are market clearing prices?
I think, and in addition, right, there is also the problem of inferencing a small model is quite easy, right? I can run Llama 70B on one AMD GPU. I can run Llama 70B on one Nvidia GPU, and soon enough there will be on one set of Amazon's new Trainium, right? I can sort of run this model on a single chip. This is a very easy, I won't say very easy problem, it's still hard, but it's a quite a bit easier problem than running this complex reasoning or this very large model, right? And so there is that difference, right? There's also the fact that, hey, there's literally 15 different companies out there offering API inference APIs on Llama and Alibaba and DeepSeek and Mistral, like these different models, right?
You're talking about Cerebrus and Grok and, Fireworks and all these others.
Yeah, Fireworks together, all the companies that aren't using their own hardware. Now, of course, Grok and Cerebrus are doing their own hardware and doing this as well. But the market, the margins here are bad, right? Sort of we had this whole thing about the inference race to the bottom when Mistral released their Mistral model, which was like very revolutionary sort of late last year, because it was such a level of performance that didn't exist in the open source, that it drove pricing down so fast, right? Because everyone's competing for API. What am I as an API provider providing you that, like, why don't you switch from mine to his? Why? Right. Because, it's pretty fungible, right? I'm still getting the same tokens on the same model. And so the margins for these guys is much lower. So Microsoft's earning 50 to 70% gross margins on OpenAI models. And that's with the profit share they get to get, or the share that they give OpenAI, right? Or, Anthropic, similarly in their most recent round, they were showing like 70% gross margins. But that's because they have this model. You step down to here, no one uses this model a lot less people use it from OpenAI or Anthropic because they can just like take the weights from Llama, put it on their own server, or vice versa. Go to one of the many competitive API providers, some of them being venture funded, some of them, and losing money, right? So there's all this competition here. So not only are you saying, I'm taking a step back and it's an easier problem, and so therefore, like if the model's 10x smaller, it's like 15x cheaper to run. And on top of that, I'm removing that gross margin. And so it's not 15x cheaper to run, it's 30x cheaper to run. And so this is sort of the beauty of like, well, is everything commodity? No, but like there is a huge chase to like, if you're deploying it in services, this is great for you, A. Right. B, you have to have the best model or you're no one if you're one of the labs, right? And so you see a lot of struggles for the companies that were trying to build the best models but failing, right?
And arguably, not only do you have to have the best model, you actually have to have an enterprise or a consumer willing to pay for the best model, right? Because at the end of the day, the best model implies that somebody's willing to pay you these high margins, right? And that's either an enterprise or a consumer. So I think, you're quickly narrowing down to just a handful of folks who will be able to compete, in that market.
I think on the model side, yes. I think on the who's willing to pay for these models is, I think a lot more people will pay for the best model, right? When we use models internally, right? We have language models go through every regulatory filing and permit to look at data center stuff and pull that out and tell us where to look and where to not to. And we just use the best model because it's so cheap, right? Like the data that I'm getting out of it, the value I'm getting out of it is so much higher.
What model are you using?
We're using Anthropic actually right now, Claude 3.5 Sonnet new, Sonnet. And so just because O1 is a lot better on certain tasks, but not necessarily regulatory filings and permitting and like things like that, because the cost of errors is so much higher, right? Yeah. Same with a developer, right? If I can increase a developer who makes $300,000 a year here in the Bay by 20%, that's a lot. If I can take a team of 100 developers and use 75 or 50 to do the same job, or I can ship twice as much code, this is so worth using the most expensive model because O1, as expensive it is relative to 4.0, is still super cheap, right? The cost for intelligence is so high in society, right? That's why intelligent jobs are the most, high-paying jobs. White-collar jobs, right, are the most high-paying jobs. If you can bring down the cost of intelligence or augment intelligence, then there's a high market clearing price for that, which is why I think that like sort of O1 is expensive, and people will always gravitate to what's the cheapest thing at a certain level of intelligence. But each time we break a new level of intelligence, it's not just, we've got a few more tasks we can do. I think it grows the mode of tasks that can be done dramatically. Very few people could use GPT-2 and 3, right? A lot of people can use GPT-4. When we get to that quality of jump that we see for the next generation, a amount of people that can use it, the tasks that it can do balloons out, and therefore the amount of sort of white collar jobs that it can augment and increase productivity on will grow, and therefore the market clearing price for that token will be very
That's super interesting. I could make the other argument that someone that's in a high volume, this replacing tons of customer service calls or whatever, might be tempted to minimize the spend.
Absolutely.
And maximize the amount of value add they build around this thing, database writes and reads.
Absolutely. So one of the funny things I like to, the calculations we did is if you take 1/4 of NVIDIA's shipments and you said all of them are going to inference Llama 7B, you can give every single person on Earth 100 tokens per minute, right? 100 tokens per second. You can give every single person on Earth 100 tokens per second, which is like absurd.
Yeah.
So like if we're just deploying Llama 7B quality models, we've so overbuilt, it's not even funny. Now, if we're deploying things that can like augment engineers and increase productivity and help us build robotics or AV or whatever else faster, then that's a very different like calculation, right? And so that's sort of the whole thing. Like, yes, small models are there, but like they're so easy to run.
And it may just, both these things may be true.
Right. We're going to have tons of small models running everywhere, but the compute cost of them is so low.
Yeah. Fair enough.
Bill and I were talking about this earlier with respect to the hard drives, that you used to cover. But if you look at the memory market, it's been one of these boom or bust markets. The idea was you would always, sell these things when they're nearing peak. You always buy them at trough. You don't own them anywhere in between. They trade at very low earnings multiples. I'm talking about Hynix and I'm talking about, Micron. As you think about the shift toward inference time compute, it seems that the memory demanded of these chips, and Jensen has talked a lot about this, just is on a secular shift higher. Right? Because if they're doing these passes, and you're running, like you said, 10 or 100 or 1,000 passes for inference time reasoning, you just have to have more and more memory as this context length expands. So, talk to us a little bit about, kind of how you think about the memory market.
Yeah. So, to sort of like set the stage a little bit more is reasoning models output thousands and thousands of tokens.
Yeah.
And when we're looking at transformers, attention, right, the like holy grail of transformers, i.e. how it like understands the entire context, grows dramatically, and the KV cache, i.e. the memory that is keeping track of what this like context means,
Correct.
is growing quadratically, right? And therefore, if I go from a context length of 10 to 100, it's not just a 10x, it's much more, right?
Mm-hmm.
And so you treat that, right? Like today's reasoning models, they'll think 10,000 tokens, 20,000 tokens. When we get to, hey, what is complex reasoning going to look like? Models are going to get to the point where they're thinking for hundreds of thousands of tokens. And then this is all one chain of thought, or it might be some search, but it's going to be thinking a lot, and this KV cache is going to balloon.
So
right?
you're saying memory could grow faster than GPU.
And it objectively is when you look at the cost of goods sold of Nvidia.
Right.
Their highest cost of goods sold is not TSMC, which is a thing that people don't realize. It's actually HBM memory, primarily SK Hynix.
That may be a for now also, but
yeah. So yeah, there's three memory companies out there, right? There's Samsung, SK Hynix, and Micron. Nvidia has majority used SK Hynix, and this is like a big shift in the memory market as a whole, because historically it has been a commodity, right? I.e., it's fungible. Whether I buy from Samsung or SK Hynix or Micron,
is the socket replaceable?
Yeah. And even now, Samsung is getting really, really hit hard because there's a Chinese memory maker, CXMT, and their memory's not as good as the West, but it's fine. And in low-end memory, it's fungible. And therefore, the price of low-end memory has fallen a lot.
Correct.
In HBM, Samsung has almost no share, right? Especially at NVIDIA. And so this is hitting Samsung really hard, right? Even despite them being the largest memory maker in the world, everyone's always like, if you said memory, it's like, yeah, Samsung's a little bit ahead in tech and their margins are a little bit better and they're killing it, right? But now it's not the case, because on the low end, they're getting a little bit hit, and on the high end, they can't break in, or they keep trying, but they keep failing. On the flip side, you have companies like SK Hynix and Micron who are converting significant amounts of their capacity of, sort of commodity DRAM to HBM. Now, HBM is still fungible, right? In that if someone hits a certain level of technology, they can swap out Micron to Hynix, right? So
Correct.
it's fungible in that sense, right? It's a commodity in that sense. But because reasoning requires so much more memory and the cost of goods sold of an H100 to Blackwell, the percentage of cost to HBM has grown faster than the percentage of cost to leading edge silicon. You've got this big shift or dynamic going on. And this applies not just to NVIDIA's GPUs, but it applies to the hyperscalers' GPUs as well, right? Or accelerators like the TPU, Amazon Trainium, et cetera.
And SK has higher gross margins than memory companies have.
Correct. If you listen to Jensen at least describe it, it's not all memory is created equal. Right. And so it's not only that the product is more differentiated today, there's more software associated with the product today, but it's also how it's integrated into the overall system. Right. And going back to the supply chain question, it sounds like it's all commodity. It just seems to me that at least there's a question out there. Is it structurally changing? We know the secular curve is up and to the right.
I'm hearing you say maybe. It may be differentiated enough to not be a commodity.
It may be. And I think another thing to point at is funnily enough, the gross margins on HBM have not been fantastic.
Right.
They've been good, but they haven't been fantastic. Actually, regular memory, high-end like server memory that is not HBM is actually higher gross margin than HBM. And the reason for this is because NVIDIA is pushing the memory makers so hard, right? They want the faster, newer generation of memory faster and faster and faster for HBM, but not necessarily like everyone else for servers. Now, what is this meant? Is that, hey, even though Samsung may achieve level 4, right, or level 3 or whatever that they had previously, they can't reach what Hynix is at now. What are the competitors doing, right? What is AMD and Amazon saying? AMD explicitly has a better inference GPU because they give you more memory, right? They give you more memory and more memory bandwidth. That's literally the only reason AMD's GPU is even considered better
on chip.
HBM memory, which is on package, right? Specifically, yeah. And then when we look at Amazon, their whole thing at reInvent, if you really talk to them when they announced Trainium 2, and our whole post about it and our analysis of it is like supply chain wise, you squint your eyes, this looks like an Amazon Basics TPU, right? It's decent, right? But it's really cheap, A, and B, it gives you the most HBM capacity per dollar and most HBM memory bandwidth per dollar of any chip on the market. And therefore, it actually makes sense for certain applications to use. And so this is like a real shift. Like, hey, we maybe can't design as well as NVIDIA, but we can put more memory on the package, right? Now, this is just only one vector of like, there's a multi-vector problem here. They don't have the networking nearly as good. They don't have the software nearly as good. Their compute elements are not nearly as good, but they've got more memory bandwidth per dollar.
Well, this is where we wanted to go before we run out of time, is just to talk about these alternatives, which you just started doing. So despite all the amazing reasons why no one would seemingly want to pick a fight with NVIDIA, many are trying, right? And I even hear people talk about trying that haven't tried yet, like OpenAI is constantly talking about their own chip. How are these other players doing? Like, how would you handicap? Let's start with AMD, just because they're a standalone company, and then we'll go to some of the internal programs.
Yeah, so AMD is competing well because silicon engineering wise, they're amazing. Right, they're competitive.
Kicked
potentially,
Intel's ass.
But yeah, they kicked Intel's ass. But that's like stealing candy from a baby. Come on,
they started way down here. Over a 20-year period, it was pretty amazing.
So AMD is really good, but they're missing software. AMD has no clue how to do software. I think they've got very few developers on it. They won't spend the money to build a GPU cluster for themselves so that they can develop software. Right, which is like insane. Right, like NVIDIA. The top 500 supercomputer list is not relevant because most of the biggest supercomputers like Elon's and Microsoft's and so on and so forth are not on there. But NVIDIA has multiple supercomputers on the top 500 supercomputer list, and they use them fully internally to develop software, network software, whether it be network software, compute software, inference software, all these things. Test all these changes they make. And then roll out pushes, where if XAI is mad because of, software is not working, NVIDIA will push it the next day or 2 days later, like clockwork, right? Because there's tons of things that break constantly when you're training models. Right. AMD doesn't do that, right? And I don't know why they won't spend the money on a big cluster. The other thing is they have no idea how to do system level design. They've always lived in the world of I'm competing with Intel, so if I make a better chip than Intel, then I'm great. Because software, x86, it's x86.
Presumably
everything's fungible.
I mean, NVIDIA doesn't keep it a secret that they're a systems company, so presumably they've read that and they're
and so they bought this systems company called ZT Systems. But they're, the whole rack scale architecture, which Google deployed in 2018 with the TPU, V3.
Are there any hyperscalers that are so interested in AMD being successful that they're co-developing with them?
So the hyperscalers all have their own custom silicon efforts, but they also are helping AMD a lot in different ways, right? So Meta and Microsoft are helping them with software, right? Not enough that like AMD is like caught up or anything close to it. They're helping AMD a lot with what they should even do, right? So the other thing that people don't recognize is if I have the best engineering team in the world, that doesn't tell me what the problem is, right? The problem has this. It's got these trade-offs. AMD doesn't know software development. It doesn't know model development. It doesn't know what inference economics look like. And so how do they know what trade-offs to make? Do I push this lever on the chip a bit harder, which then makes me have to back off on this? Or what exactly do I do, right? But the hyperscalers are helping, but not enough that AMD is on the same timelines as Nvidia.
How successful will AMD be in the next year on AI revenue, and what kind of sockets might they succeed in?
Yes, I think they'll have a lot less success with Microsoft than they did this year, and they'll have less success than they did with Meta than they did this year. And this is because like the regulations make it so actually AMD's GPU is like quite good for China because of the way they shaped it. But generally, I think AMD will do okay. They'll profit from the market. They just won't like go gangbusters like people are hoping. And they won't be their share of total revenue will fall next year.
Okay.
But they will still do really well, right? Billions of dollars of revenue is nothing to scoff at.
Let's go with the Google TPU. You earlier stated that it's got the second most workloads. It seems like by a lot. Like it's firmly in second place.
Yeah, so this is where the whole systems and infrastructure thing matters a lot more. Each individual TPU is not that impressive. It's impressive, right? It's got good networking, it's got good architecture, etc. It's got okay memory, right? Like it's not that impressive on its own. But when you say, hey, if I'm spending X amount of money, and then what's my system? Google's TPU looks amazing, right? So Google's engineered it for things that Nvidia maybe has not focused on as much, right? So actually their interconnects between chips is arguably competitive, if not better in certain aspects, worse in other aspects than Nvidia's, because they've been doing this with Broadcom, the world leader in networking, building a chip with them. And since 2018, they've had this scale up, right? Nvidia's talking about GB200 NVL72, TPUs go to 8,000 today, right? And while it's not a switched, it's a point to point, it's a little bit, there's some technical nuances there. So it's not just like that, those numbers are not all you should look at, but this is important. The other aspect is Google's brought in water cooling for years, right? Nvidia only just realized they needed water cooling on this generation. And Google's brought in a level of reliability that Nvidia GPUs don't have. The dirty secret is to go ask people what the reliability rate of GPUs is in the cloud or in a deployment. It's like, oh God, they're reliable-ish. But especially initially, you have to pull out like 5% of them.
Why has TPU not been more commercially successful outside of Google?
I think Google keeps a lot of their software internal when they should just have it be open because who cares? That's one aspect of it. There's a lot of software that DeepMind uses that just is not available to Google Cloud. Right. Two,
even their Google Cloud offering relative to AWS had that bias.
Way back. Yeah. Number two, the pricing of it is sort of. It's not that it's egregious on list price. Like list price of a GPU at Google Cloud is also egregious. Right. But you as a person know when I go rent a GPU. I tell Google hey, blah, blah, blah. You're like, okay, you can get around the first round of negotiations, get both down. But then you're like, well, look at this offer from Oracle or from Microsoft or from Amazon or from CoreWeave or one of the 80 neo clouds that exist. And Google might not match many of these companies, but they'll go down because they, and then you're like, oh, well, what's the market clearing price for if I wanted an H100 for 2 years or a year? Oh yeah, I could get it for $2.
Right.
A little bit over versus the $4 quoted. Right. Whereas a TPU, it's here. You don't know that you can get here. And so people see the list price and they're like, ah.
Do you think that'll change?
I don't see any reason why it would. And so number three is sort of Google is better off using all of their TPUs internally. Microsoft rents very few GPUs, by the way, right? They actually get far more profit from using their GPUs for internal workloads or using them for inference because the gross margin on selling tokens is 50 to 70%. Right? The gross margin on selling a GPU server is lower than that, right? So while it is like good gross margin, it's like, it's
they've said out of the 10 billion that they've quoted, none of that's coming from external renting of GPUs.
If Gemini becomes hyper competitive as an API, then you indirectly will have third parties using the Google TPU. Is that accurate?
Yeah, absolutely. Ads, search, Gemini applications, all of these things use TPUs. So it's not that like, that you're not using every YouTube video you upload is going through a TPU, right? Like, it goes through other chips as well that they've made themselves, custom chips for YouTube. But like, there's so much that touches a TPU, but you directly would never rent it, right? And that's therefore like, when you look at the market of renters, there's only one company accounts for over 70% of Google's revenue from TPUs, as far as I understand, and that's Apple, right? And I think there's a whole long story around why Apple hates Nvidia. But that may be a story for another time. But
you just did a super deep piece on Trainium. Why don't you do the Amazon version of what you just did with Google?
Yeah, so funnily enough, Amazon's chip is the Amazon. I call it the Amazon's Basics TPU, right? And the reason I call it that is because yes, it uses more silicon. Yes, it uses more memory. Yes, the network is like somewhat comparable to TPUs, right? It's a 4x4x4 Taurus. They just do it in a less efficient way in terms of, hey, they're spending a lot more on active cables, right? Because they're working with Marvell and Alchip on their own chips versus working with Broadcom, the leader in networking, who then can use passive cables, right? For because their SerDes are so strong. Like there's other things here. Their SerDes speed is lower. They spend more silicon area. Like there's all these things about the Trainium that are, you could look at it and be like, wow, this would suck if it was a merchant silicon thing, but it doesn't, because it's Amazon's not paying Broadcom margins, right? They're paying lower margins. They're not paying the margins on the HBM. They're paying lower margins in general, right? Paying the margins to Marvell on HBM. There's all these different things they do to crush the price down to where their Amazon Basics TPU, the Trainium 2, right, is very, very cost effective to the end customer and themselves in terms of HBM per dollar, memory bandwidth per dollar, and it has this world size of 64. Now, Amazon can't do it in one rack. It actually requires them 2 racks to do 64, and the bandwidth between each chip is much slower than NVIDIA's rack. And their memory per chip is lower than NVIDIA's, and their memory bandwidth per chip is lower than NVIDIA. But you're not paying, north of $30,000, $40,000 for this per chip for the server. You're paying, significantly less, right? $5,000 per chip, right? Like, it's like such a gulf, right, for Amazon, and then they pass that on to the customer, right? Because when you buy an Nvidia GPU, so there is legitimate use cases, and because of this, right, Amazon and Anthropic have decided to make a 400,000 Trainium server supercomputer, right? 400,000 chips, right? Going back to the scaling law is dead. No, they're making a 400,000 chip system because they truly believe in this. Right. And 400,000 chips in one location is not useful for serving inference, right? It's useful for making better models, right? You want your inference to be more distributed than that. So this is a huge investment for them. And while technically it's not that impressive, there are some impressive aspects that I kind of glossed over. It is so cheap and so cost effective that I think it's a decent play for Amazon.
Maybe just wrapping this up, I want to shift a little bit to kind of what you see happening in 25 and 26, right? For example, over the last 30 days, right, we've seen Broadcom, explode higher, Nvidia trade off a lot. I think there's about a 40% separation over the last 30 days, with Broadcom being this play on custom ASICs, people questioning whether or not Nvidia's got a lot of new competition, pre-training, not improving at the rate that it was before. Look into your crystal ball for 25, 26. What are you talking to clients about, in terms of what you think are kind of the things that are most misunderstood, best ideas, in the spaces that you cover?
So I think a couple of the things are, hey, Broadcom does have multiple custom ASIC wins, right? It's not just Google here. Meta's ramping up mostly still for recommendation systems, but their custom chips are going to get better. There's other players like OpenAI who are making a chip, right? There's Apple who are not quite making the whole chip with Broadcom, but a small portion of it will be made with Broadcom, right? There's a lot of wins they have, right? Now these all won't hit in 25. Some of them will hit in 26, and it's it's a custom ASIC, so like it could be a failure and not be good, like Microsoft's, and therefore never ramp, or it could be really good and or at least good price to performance like Amazon's, and it can ramp a lot, right? So there are risks here, but Broadcom has that custom ASIC business, one, and two, really importantly, the networking side is so important, right? Yes, Nvidia is selling a lot of networking equipment, but when people make their own ASIC, what are they going to do, right? Yes, they could go to Amazon or not, but they also need to network many of these chips together. To Broadcom or not. They could go to Marvell or many other competitors out there like Alchip or and GUC. Like Broadcom is really well positioned to make the competitor to NVSwitch, which many would argue is one of Nvidia's biggest competitive advantages on a hardware basis versus everyone else. And Broadcom is making a competitor to that they will cede to the market, right? Multiple companies will be using that. Not just, AMD will be using that competitor to NVSwitch, but they're not making it themselves because they don't have the skills, right? They're going to Broadcom to get it made, right?
So make a call for us as you think about the semis market today. You've got ARM, Broadcom, you've got Nvidia, you've got AMD, et cetera. Does the whole market continue to elevate as we head into 25 and 26? Who's best positioned from current levels to do well? Who's most, overestimated? Who's most underestimated?
I think I love Broadcom long term, but like in the next 6 months, there is a bit of a slowdown in Google TPU purchases because they have no data center space. They want more. They just literally have no data center space to put them. So we actually can see how they're like there's a bit of a pause. But people may look past that. Beyond that, right? It's the question is like who wins what custom ASIC deals, right? Is Marvell going to win future generations? Is Broadcom going to win future generations? How big are these generations going to be? Are the hyperscalers going to be able to internalize more and more of this or no, right? Like it's no secret Google's trying to leave Broadcom. They could succeed or they could fail, right? It's not just like
broaden out beyond Broadcom. I'm talking Nvidia and everybody else. Like, we've had these 2 massive years, right, of tailwinds behind this sector. Is 2025 a year of consolidation? Do you think it's another year that the sector does well? Just kind of
I think the plans for hyperscalers are pretty firm on they're going to spend a crap load more next year, right? And therefore, the ecosystem of networking players, of ASIC vendors, of systems vendors is going to do well, whether it be Nvidia or Marvell or Broadcom or AMD or generally some better than others. The real question that people should be looking out to is 2026. Does the spend continue? Right? We are not the growth rate for Nvidia is going to be stupendous next year, right? And that's going to drag the entire component supply chain up. It's going to bring so many people with them. But 2026 is like where the reckoning comes, right? But will people keep spending like this? And it's all points to where will the models continue to get better? Because if they don't continue to get better, in my opinion, will get better faster. In fact, next year, then there will be a big sort of clearing event, right? But that's not next year, right? The other aspect I would say is there is consolidation in the neocloud market, right? There are 80 neoclouds that we're tracking that we talk to, that we see how many GPUs they have, right? The problem is nowadays, if you look at rental prices for H100s, they're tanking, right? Not just at these neoclouds, right? Where you used to have to pay, do 4-year deals and prepay 25%. You'd sign a venture round and you'd buy a cluster and that's about it, right? You'd rent one cluster, right? Nowadays, you can get 3-month, 6-month deals at way better pricing than even the 4-month or the 4-year, 3-year deals that you used to have for Hopper, right? And on top of that, it's not just through the neoclouds. Amazon's pricing for on-demand GPUs is falling. Now it's still really expensive relatively, but like pricing is falling really fast. 80 neoclouds are not going to survive. Maybe 5 to 10 will.
Right.
And that's because 5 of those are sovereign, right? And then the other 5 are like actually like market competitive.
What percentage of the industry AI revenues have come from those neoclouds that may not survive?
Yeah, so roughly you can say hyperscalers are 50-ish% of revenue, 50 to 60%, and the rest of it is neocloud / sovereign AI. Because enterprises' purchases of GPU clusters is still quite low, and it ends up being better for them to just like outsource it to neoclouds when they can like get through the security, which they can for certain companies like CoreWeave and.
Is there a scenario where in 2026 where you see industry volumes actually down versus 2025, or Nvidia volumes actually down meaningfully from 2025?
So when you look at custom ASIC designs that are coming, as well as NVIDIA's chips that are coming, the revenue, the content in each chip is exploding.
Correct.
The cost to make Blackwell is north of 2x that of the cost to make Hopper, right? So NVIDIA can make the same, and obviously they're cutting margins a little bit, but NVIDIA can ship the same volumes and still grow a ton, right?
Correct. So rather than unit volumes,
yeah,
is there a scenario where industry revenues are down in 26, or NVIDIA revenues are down in 26?
I mean, the reckoning is, do models continue to get much better? And will hyperscalers, are they okay with taking their free cash flow to zero? I think they are, by the way. I think Meta and Microsoft may even take their free cash flows close to zero and just spend. But then that's only if models continue to get better. That's A. And then B, are we going to have this huge influx of capital from people we haven't had it yet from? The Middle East, the sovereign wealth funds in Singapore and Nordics and Canadian pension fund and all these folks. They can write really big checks. They haven't, but they could. And if things continue to get better, I truly do believe that OpenAI and XAI and Anthropic will continue to raise more and more money and keep this game going of not just, hey, where's the revenue for OpenAI? Well, it's $8 billion and it might double or whatever, or even more next year. And that's their spend. No. Like they have to raise more money to spend significantly more. And that keeps the engine rolling, because once one of them spends, Elon is forcing everyone to spend more, actually, right? With his cluster, because his plans, because everybody's like, well, we can't get outscaled by Elon. We have to spend more, right? And so there's sort of a game of chicken there too. We're like, oh, they're buying this. We have to match them or go bigger, because it is a game of scale. So in sort of Pascal's wager sense, right? If I underspend, that's just the worst scenario ever. And I'm like the worst CEO ever of the most profitable business ever. But if I overspend, yeah, shareholders will be mad, but it's fine, right? It's, $20 billion, $50 billion.
You can paint that either way, though, because if that becomes the reasoning for doing it, you're more, the probability of overshooting goes up.
For sure.
And every bubble ever we overshoot. Now,
and to me, you said it all hangs on models improving. I would take it a step further, and go back to what Satya said to us last week. It all comes down ultimately to the revenues that are generated by the people who are making the purchases of the GPUs, right? Like he said last week, I'm going to buy a certain amount every single year, and it's going to be related to the revenues that I'm able to generate in that year or the next couple of years. So like they're not going to spend way ahead of where those revenues are. So he's looking at what, he had 10 billion in revenues this year. He knows the growth rate associated with those inference revenues, and he and Amy are making some forecast as to what they can afford to spend. I think Zuckerberg's doing the same thing. I think Sundar's doing the same thing. And so if you assume they're acting rationally, it's not just the models improving, it's also the rate of adoption of the underlying, enterprises who are using their services. It's the rate of adoption of consumers and what consumers are willing to pay to use ChatGPT or to use Claude or to use these other services. So, if you think that infrastructure expenses are going to grow at 30% a year, then I think you have to believe that the underlying inference revenues, right, both on the consumer side and the enterprise side, are going to grow somewhere in that range as well.
There is definitely an element of spend ahead, though, right? And it's
sure.
Point in time spend versus, what do I think revenue will be for the next 5 years for this server, right? So I think there is an element of that for sure, but absolutely, right? Models, the whole point is models getting better is what generates more revenue, right? And it gets deployed. So I think I'm in agreement, but people are definitely spending ahead of what's charted.
Fair enough.
Well, that's what makes it spicy. It's fun to have you here. I mean, a fellow analyst, you guys do a lot of digging. Congratulations on the success of your business. I think you add a lot of important information to the entire ecosystem. One of the things I think about the wall of worry, Bill, is the fact that we're all talking about and looking for, right, the bubble. Sometimes that's what prevents the bubble from actually happening. But, as both an investor and an analyst, I look at this and I say there are definitely people out there who are spending who don't have commensurate revenues. To your point, spending way ahead. On the other hand, and frankly, we heard that from Satya last week. He said, "Listen, I've got the revenues. I've said what my revenues are. I haven't heard that from everybody else." Right. And so it'll be interesting to see in 2025 who shows up with the revenues. I think you already see some of these smaller second and third tier models changing business model, falling aside, no longer engaged in the arms race, of investment here. I think that's part of the creative destructive process, but it's been fun having you on.
Yeah. Thank you so much, Dylan. Really appreciate it.
Yeah. Fun having you here in person, Bill. And until next year.
Awesome. Thank you.
Take care.
As a reminder to everybody, just our opinions, not investment advice.